Ever wonder how ancient inventors created machines that seem to work like magic? A lot of it comes down to a few simple, brilliant ideas. Today, we're diving deep into the mind of one of history's greatest engineers, Heron of Alexandria, and a concept he mastered, the pair principle. Now, what exactly is the pair principle? Simply put, it's the idea of using two identical or opposite components working together to create a stable, balanced, or more powerful effect. Think of it like using two hands to lift a heavy box instead of one. It's more stable, and you have more control. Heron, living way back in the 1st century AD, was a master of this. He didn't just think about it, he built with it. Let's look at one of his most famous inventions, the Iolipile. You might have seen it in textbooks. It's often called the first steam engine. It's a sphere with two bent nozzles pointing in opposite directions, mounted on a pivot. When you boil water inside, steam shoots out of the nozzles. Because the nozzles are a pair, pointing in opposite directions, their forces work together to spin the sphere. It's a perfect example of a balanced, rotational force created by a pair. One nozzle alone would just push the sphere sideways. Two nozzles create a turning couple, a pure rotation. That's the pair principle in action. But Heron didn't stop with spinning spheres. He applied this concept to solve real-world problems. Take his design for a self-filling wine bowl. It was a party trick that amazed his guests. The setup used a hidden counterweight system. When a guest took wine from the bowl would become lighter. This allowed a counterweight to drop, which opened a valve connected to a hidden wine reservoir. Wine would flow into the bowl until it was heavy enough to lift the counterweight again, closing the valve. It's a pair of opposing forces, the weight of the wine and the counterweight, constantly balancing each other out to maintain a perfect level. It's an early feedback loop, all thanks to this simple idea of pairing. Another incredible example is found in his designs for automated temple doors. Imagine walking up to a temple, lighting a fire on the altar, and watching the massive doors swing open on their own. It felt like divine intervention, but it was pure engineering genius. Here's how the pair principle was at work. The heat from the altar fire would expand the air in a hidden chamber. This expanding air would push water from one container into another, a bucket. This bucket, now heavy, would pull on a system of ropes and pulleys. The ropes were wrapped around a pair of vertical pivots, one for each door. As the bucket descended, it pulled the ropes, causing the two pivots to rotate in opposite directions, swinging the huge doors open. A pair of pivots, a pair of doors, all working in beautiful, synchronized harmony. Why is this so important? The pair principle is all about creating stability and control. By using two opposing forces or two identical components, Heron could cancel out unwanted movements and create precise, intended actions. A single force pushes a pair of forces can rotate, stabilize, or create a balanced system. It's the difference between a clumsy, brute force solution and an elegant, efficient machine. This concept is fundamental to engineering even today. Think about the wheels on your car, they work in pairs. The wings on an airplane, a pair. The pistons in many engines, they fire in balanced pairs. Heron of Alexandria was more than just an inventor of curious gadgets. He was a systematic thinker who understood the fundamental principles of mechanics. His use of the pair principle shows a deep understanding of symmetry, balance, and force. He laid the groundwork for so many technologies we take for granted. By looking at his ancient designs, we can see the seeds of modern robotics, automation, and mechanical engineering. It reminds us that sometimes, the most powerful ideas are the simplest ones, brilliantly applied. So the next time you see a machine working smoothly, look for the pairs. Look for the symmetry and the balance. You might just be seeing the timeless genius of Heron of Alexandria at work, over 2,000 years later. Thanks so much for nerding out with me about ancient engineering. If you enjoyed this journey back in time, be sure to hit that like button and subscribe for more deep dives into the history of technology. See you in the next video.